Hey, cosmic explorers! Ever wondered about the universe's most mind-blowing phenomena? Welcome back to the cosmic frontier. Today, we're diving into an interstellar showdown. Quasars versus pulsars versus magnetars versus black holes. What are they? How are they different? And which one's the ultimate cosmic powerhouse? These are the kinds of questions that keep me up at night, and should keep you up too. Stick around to find out. First up, quasars. Now, these aren't your everyday run-of-the-mill stars. Oh no, a quasar is something entirely different. Imagine a cosmic lighthouse, but instead of a bulb, it's powered by a supermassive black hole, sitting right there at the center of a galaxy. And when matter gets too close, you know what happens? It spirals into that black hole, heats up to unimaginable temperatures, and releases these mind-boggling amounts of energy. We're talking about a galactic fireworks show on steroids, folks. Now here's a fun fact that'll really bake your noodle. The brightest quasars out there, they can outshine their entire galaxy. They're like the divas of the universe, demanding all the attention. But here's the catch. You wouldn't want to get too close to one of these cosmic celebrities. That energy, it would fry anything in its path. No sunscreen strong enough. You see, quasars are fascinating because they tell us a lot about the early universe. They're like looking back in time billions of years ago to when galaxies were still forming. It's like having a time machine, but instead of a clunky DeLorean, we have these incredibly bright objects billions of light years away, and the sheer power of quasars. It boggles the mind to think about the forces at play, the immense gravity of the black hole, the incredible speeds at which matter is swirling around, and the sheer amount of energy being released. It's enough to make you feel very, very small, but that's the beauty of astronomy, isn't it? It reminds us of the vastness of the universe and how much we still don't know. And that's what makes it so exciting. Every new discovery opens up a whole new set of questions and possibilities. Next up, we've got pulsars. Now picture this. A star spinning so fast, it would make a figure skater dizzy, sending out beams of light like a cosmic disco ball. That's a pulsar for you. But these aren't just any stars. Pulsars are neutron stars, the remnants of massive stars that went out with a bang, a supernova explosion. What's left behind is this incredibly dense object, about the size of a city but packing the mass of our sun. And those beams of light? They're so precise, so regular. They're like nature's most accurate clocks. In fact, NASA actually uses pulsars to help navigate spacecraft. Talk about cosmic GPS. Now you might be wondering, how can a dead star still be spinning and emitting light? Well, it's all about physics, my friends. When a massive star collapses, it conserves its angular momentum, which basically means it spins faster and faster. And as it spins, its magnetic field gets amplified, creating these powerful beams of radiation. These beams are so focused, they sweep across space like a lighthouse beam. And just like a lighthouse, we only see the beam when it's pointed directly at us. That's why pulsars appear to pulse. But here's the thing about pulsars. They're not just fascinating objects to study. They're also incredibly useful tools for astronomers. By studying the way pulsars pulse, we can learn about the properties of matter under extreme conditions, like the density and pressure inside neutron stars. We can also use pulsars to study gravity. You see, Einstein's theory of general relativity predicts that massive objects, like pulsars, should warp the fabric of space-time. And by studying the way radio waves from pulsars are bent by the gravity of other stars, we can actually test Einstein's theory. Chapter 3. Magnetars don't get too close. Okay, we've talked about pulsars, those spinning flashing wonders. But hold on to your hats, folks, because now we're entering the realm of the extreme. Get ready for magnetars. Pulsars are cool and all, but magnetars? They're next level, off-the-charts extreme. These neutron stars, they're like the rebellious teenagers of the cosmos, with magnetic fields so strong, they make a refrigerator magnet look like a weak handshake. We're talking 1 trillion times stronger than Earth's magnetic field. That's so strong if you were within, say, 1,000 kilometers of one of these bad boys, its magnetism would literally rip you apart, atom by atom. Not a pleasant way to go. Magnetars are like the ninjas of the universe, rare and elusive. But when they do decide to show off, they make a grand entrance, creating these incredibly powerful gamma-ray bursts, some of the most energetic events we've ever witnessed in the cosmos. Imagine this. In a fraction of a second, a magnetar can release more energy than our sun will emit in its entire lifetime. That's like taking all the energy from the sun and squeezing it into a split second. It's mind-blowing. Now, you might be thinking, what causes these insane magnetic fields? Well, scientists believe it's all about how magnetars are born. You see, when a massive star collapses, It can sometimes leave behind a core that's spinning incredibly fast and has a very strong magnetic field. And under the right conditions, this magnetic field can get amplified even further, creating a magnetar. It's like taking a dynamo and cranking it up to 11. But magnetars are still a mystery in many ways. We don't know exactly how they form, how long they last, or even how many are out there. But that's what makes them so exciting to study. They're like a cosmic puzzle just waiting to be solved. Chapter 4. Black holes, the ultimate cosmic mystery. And finally, we arrive at the ultimate cosmic celebrity, the one everyone wants a selfie with, but nobody gets close enough to take. Black holes. These are the cosmic enigmas, shrouded in mystery, that have captivated our imaginations for centuries. Black holes are regions of space-time where gravity is so strong, so intense that nothing, not even light, can escape their pull. It's like a cosmic vacuum cleaner, sucking up everything in its path. Now, some black holes are born from the death throes of massive stars, collapsing in on themselves. But others, the supermassive black holes, they lurk in the hearts of galaxies, like cosmic giants, gobbling up anything that ventures too close. But here's the real head-scratcher. What happens inside a black hole? That, my friends, is one of the biggest mysteries in all of science. It's like trying to peek behind the curtain of reality itself. Some theories suggest that time might stop inside a black hole, or that space could become so warped, it's like falling into a bottomless pit. And then there's the possibility of wormholes, those hypothetical tunnels that could connect different points in space-time. But here's the thing about black holes. They're not just science fiction, they're very real, and we have evidence of their existence all over the universe. We see stars orbiting around invisible objects, their paths warped by the immense gravity of a black hole. We see jets of matter being blasted out from the centers of galaxies, powered by the energy released as matter falls into a black hole. And we even have images of the shadows of black holes, thanks to the Event Horizon Telescope. Black holes are a reminder that there's still so much we don't know about the universe. But they're also a source of endless fascination and wonder. They push the boundaries of our understanding of physics and challenge us to think about the nature of reality itself. Chapter 5. The Cosmic Showdown, Who Reigns Supreme? All right, cosmic explorers, it's time for the ultimate showdown. We've met our contenders, these cosmic heavyweights, each more mind-blowing than the last. But now, the question on everyone's mind, who reigns supreme in this cosmic arena? Let's recap, shall we? In this corner, we have the Quasar, the brightest object in the known universe, powered by a supermassive black hole with an appetite for anything that gets too close. It's a cosmic beacon, shining across billions of light years. And in the other corner, we have the Pulsar, the rapidly spinning neutron star, a cosmic lighthouse with beams so precise they could make a Swiss watchmaker jealous. It's a testament to the extreme physics that can occur when a star dies. But wait, there's more. Don't forget the Magnetar, the neutron star with a magnetic field so strong it could rip apart atoms from 1,000 kilometers away. It's a cosmic force to be reckoned with, capable of unleashing bursts of energy that make supernovae look like firecrackers. And last but not least, we have the enigmatic black hole, the cosmic trapdoor where gravity reigns supreme, bending space and time to its will. It's the ultimate cosmic mystery, a place where the laws of physics as we know them break down. So who wins this cosmic showdown? Well, the truth is, there's no easy answer. It's like comparing apples and oranges or black holes and, well, everything else. Each of these objects is fascinating in its own right, with its own unique properties and behaviors, but that's the beauty of the universe, isn't it? It's full of surprises with endless possibilities and wonders waiting to be discovered. So instead of crowning a single champion, let's celebrate the diversity and grandeur of the cosmos, a place where quasars, pulsars, magnetars, and black holes can all coexist and amaze us with their cosmic dance. And who knows, maybe one day we'll unlock the secrets of these cosmic titans and gain a deeper understanding of the universe we call home. Until then, keep exploring, keep asking questions, and never stop being curious about the cosmos. Until next time, space explorers, that's a wrap on our cosmic battle. If you love this journey through the universe, don't forget to smash that like button, subscribe to the Cosmic Frontier, and hit the bell icon so you never miss an adventure. Remember, the universe is a vast and mysterious place, and we've only just scratched the surface. There's so much more to explore, so many more questions to ask. See you next time, space explorers. Keep looking up.